Many monumental milestones mark the progress of Bullard engineering through 3/4 of a century. Milestones which represent many revolutionary contributions to the machine tool industry. Ever since the Bullard nameplate was proudly affixed to the firm's first product, Bullard engineers have continued year by year to develop methods for greater manufacturing efficiency. Among their outstanding achievements is Man Au Trol, master of the machine. Man Au Trol, manual or automatic control. Here it is applied to the Bullard Cutmaster vertical turret lathe. For large quantities of duplicate pieces, Man Au Trol may be set to control the machine automatically. This spindle gear hub is a typical Manitrol product. By conventional methods, it requires 20 minutes for machining. Manitrol does it in 5 minutes and 43 seconds, effecting a saving of approximately 72%, and the machine operator is relieved of all physical effort and responsibility. Let's see how this particular job was done. A touch of the starting button and the automatic cycle is begun. For the first operation, the main head is provided with 3 different tools. These will make rough cuts first, and then will repeat their movements with the same tools, making finished cuts of highest quality at a saving in tool costs. The boring tool is the first to go into operation. It starts by making a rough bore. When it reaches the end of its cut, the next tool on the left starts to rough turn the periphery of the casting, and simultaneously the side head on the right starts to rough face the top. The last tool chamfers the top of the bore. Let us skip the finish cuts, which merely repeat the action just shown, and assume that we are through with the first set of tools. Man Au Trol commands the main head to traverse up and to index itself. The head now traverses to the left to permit the undercutting tool extending from the bar to enter the center hole of the casting. Note how 2 operations are performed simultaneously. The lower tool faces the underside of the hub, while the other tool faces the upper side. Its work completed, the head traverses back to the left, then up, and the spindle speed is changed automatically. Man Au Trol always performs with precision. Once again, the turret is indexed, automatically of course, and the reaming tool is brought into operating position. The main head automatically feeds to the right so as to center the reamer over the hole. While the reamer is performing the final operation on the hole, the side head moves in to cut a groove in the edge of the workpiece. How does Man Au Trol work? The main head and the side head are each provided with 2 sets of controls governing the vertical and horizontal movements. These controls consist of a frame in which are mounted a series of steel wires. The entire frame with its wires moves with the head. This one governs the vertical movement of the main head and travels up and down with it. Another assembly mounted horizontally on another part of the main head governs the lateral movement. Fastened immovably to the body of the machine is a row of electrical switches, 1 for each wire. Actually, there are 40 of them, but for easy visualizing, we show only a few. There is a movable stop block mounted on each wire, and this stop block may be set and secured at any point on the wire. The position of the stop block on the wire determines where a given function is to stop, and the next function is to begin. The stop block, being secured to the wires, becomes an integral part of the frame and head. When it touches the highly sensitive electric switch, it causes a low voltage current to be sent to another part of the Manitrol mechanism, stopping the present function and starting the next. These electric switches are of such precision that they operate within a tolerance of a fraction of 1/1000th of an inch. We have seen how Man Au Trol tells the machine when and where to change functions. Now we shall see how the functions are changed. This drum is arranged to receive pick-off trip dogs, which represent all the different functions required by the main head for this particular job. The positions of the dogs on the drum determine the functions and their sequence for a given job. For instance, when this trip dog comes into operating position through the rotary motion of the drum, it will cause the main head to traverse down, as indicated on the function plate. Here is a distributor arm mounted on the shaft of the drum. This arm ensures that out of 40 possible circuits, only one at a time can be energized. In other words, with the distributor arm in its present position, number 6, the drum will again index only when the circuit is closed by switch number 6. The switches may be tripped in the meantime, but the drum and distributor arm will wait for an impulse from switch number 6. Here it comes. The distributor arm passes the current along to a solenoid valve, which releases a surge of hydraulic pressure in this tube. Going back to the drum again, this time in an end view, we see in slow motion the hydraulic pressure actuating a piston and pawl, which causes the drum to index to number 7. Watch the trip dog on the underside of the drum. See how it depresses a plunger valve, which admits hydraulic pressure to a cylinder chamber and causes the clutch to engage. So, one of the functions of the main head is started. Let us say it is feeding down. Now let's look at the control mechanism again. An impulse from switch number 6 started the present function. The frame with its wires and stop blocks is feeding down with the main head. Because the distributor is now waiting for an impulse from the closing of switch number 7, this stop block on number 3 travels right on past number 3 switch and nothing happens. But here comes stop block number 7. Watch it. Contact. Through the distributor arm, the current again shoots out. It strikes the solenoid valve, releasing the hydraulic pressure again. Once more, the drum is indexed. Look again at the dog on the lower side of the drum. As it clears the plunger valve, the latter rises, cutting off the surge of hydraulic pressure and releasing the pressure already trapped in the cylinder block. A counterpressure builds up on the opposite side of a piston in the cylinder, thus disengaging the clutch and stopping the present function. For demonstration purposes, we have shown Manitrol in slow motion. In practice, it operates almost instantaneously. You have seen how Manitrol functions when in automatic operation. It works just as efficiently when in manual operation. This hand lever offers the operator his choice of motions. The machine can be instantly converted from automatic to manual operation and back again without disturbing its automatic setup for a given job. This is the skull of Manitrol. It encloses the mechanical brain which tells the machine what to do. This brain never falters, never forgets, never tires. There are 2 of these brains, one for the main head and one for the side head. All the functions of which the machine is capable are represented here. The operator of the machine has in Manitrol a centralized control over every mechanical function of the machine. Working from blueprints of the finished piece, an engineer prepares a function chart which lists every operation in its proper sequence. He takes advantage of Manitrol's ability to perform in many instances more than one operation at a time. With this chart, the operator will easily set up Manitrol for this job. The first function called for is to traverse down. So he refers to the Manitrol function plate and finds the listing traverse down. Now in row number 1 on the drum, he finds the hole directly above the words traverse down, and there he attaches one of the Manitrol trip dogs. Referring to the function chart again, he finds that the second operation is to feed right. So he looks along the function plate and finds the listing feed right, and in row number 2, in the hole directly above the desired function, he places another dog. All right, you may say, this dog will cause the machine to feed right, but different tools and different materials require different rates of feed. How does Manitrol take care of that? According to the chart, the rate of feed should be .062, and on the feed plate, .0625 appears in the D column. So, directly above the large D, the operator attaches another dog in the same row as the last, the second row on the drum. Now, .0625 appears on line number 2, so we find the large 2 and attach a dog directly above it and still on the same row. This will put 3 trip dogs in one row, and when these 3 dogs come into operating position, the head will move right and at the required rate of feed. According to the chart, the third function is to feed down. So we find feed down on the function plate, and directly above it in row number 3 we attach another dog. Thus we proceed through all the functions on the job. Rows may be left blank for other functions to be added later. So Manitrol's brain has memorized all the functions of this job and knows what to do. Next it must learn to do it. The machine is equipped with a hydraulically operated chuck, and now a rough casting of the work is placed upon the jaws. With Manitrol set for manual operation, the control lever is pulled down for the first function, traversed down, and is stopped at the correct point. Going to the detector stop block assembly, which governs the vertical movements of the main head, the operator sets a trip block on wire number 1 to make contact with switch number 1. The second function is to feed right, so he manually moves the head to the right to the approximate position required. Now to make a trial cut. Large enough? No, not quite. A few thousandths short. Just a few taps to the right. There, that should just about do it. Now to the detector stop block assembly governing the horizontal movement of the main head, and a stop block is set against switch number 2. But, you may ask, is there no finer adjustment of the stop block for jobs requiring greater precision? Yes, indeed. Manitrol offers a micrometer adjustment. The Manitrol micrometer wrench is calibrated in thousandths and fits over a precision adjusting nut on the end of the wire. At the opposite end of the wire is a spring which holds the wire under high tension. The wire and its stop block respond to the slightest adjustment of the micrometer wrench. So, Manitrol's mechanical brain has memorized what to do and where and when to do it, and with the utmost dispatch and precision. The operator follows the same procedure with each successive function for the job. Here he is about to complete the final operation, cutting a groove in the edge of the casting using the side head of the machine. This is the detector stop block assembly governing the horizontal movements of the side head, and the operator sets the stop block for the final function of the job. In order that the drum will automatically index itself to 0 upon completion of the job, all the unused stop blocks are placed in a row. Now, Manitrol is ready for the completely automatic production of this job.
Man Au Trol directs the machine through any possible pattern, no matter how complex or irregular. This is, of course, an imaginary setup and is shown only to illustrate that when the tool has completed its course, it is not obliged to retrace its path. One of Man Au Trol's many exclusive features is the fact that the tool goes back to its starting point by the shortest path. Yes, whether a few pieces or many, whatever the job may be, straight boring, turning, facing, contouring, angle turning, or other special requirements, Man Au Trol is truly master of the machine.